test, I'm going to test for the presence of sulfate ions. So what I'm going to do is first of all add a little bit of a compound that I know has got sulfate ions in it, so potassium sulfate. I'm going to add that to my test tube. I've definitely got some sulfate ions in my test tube. And now I'm going to do a test which wasn't necessary with the carbonate ions. I have to add some acid to this first, and the reason for that is that my sample, although it should be pure potassium sulfate because I've got it from the prep room, if I were testing an unknown, I wouldn't know if it was a pure chemical or not. And it's very easy for there to be things mixed in with it that might cross-contaminate my test and kind of give me a false positive. So things that can do that are hydroxide ions and carbonate ions. So if there were any potassium hydroxide or potassium carbonate mixed in with this, then I get a false positive when I was trying to do my sulfate test. The way to deal with that, always, is to add some acid. Now, acid should neutralise hydroxide ions because that's H plus and OH minus, which is a classic neutralisation. And also, we know from the previous test that acid reacts with carbonates, and I'd see some fizzing, so that would get rid of those carbonate ions as well. And that would mean that any solution I had left would have what was potentially my sulfate ions in it. Now, this adding acid potentially causes us a problem because I've got a choice of different acids that I could add. I know that I can get nitric acid, hydrochloric acid and sulfuric acid, and I need to make sure that I make the right choice. So I just want to show you something I've written down to help explain that. Okay, so in the sulfate test, I'm testing for these SO4 2- ions, the sulfate ions. And the chemical that's going to prove that they're there is this one, barium chloride. Now the theory behind that is that the barium part of the barium chloride will pair up with any sulfate ions that are in my sample to make something called barium sulfate. And that's a very thick white precipitate that's quite insoluble. And I'd see that as a really kind of milky white looking solid deposit in my test tube. Now the problem I have is if I'm supposed to add some acid before I put in my barium chloride, it's perfectly possible for me to muck up my own test. Now I'm showing you that by the choice of acids that I've got here. I could put sulfuric acid in, or I could put hydrochloric acid in. One of them would be a terrible choice and the other would be a good choice. And I wonder if you can think which one would be the good choice, which would be the terrible choice, and why. Okay, now the answer is the sulfuric acid would be the terrible choice. And the reason is sulfuric acid itself contains sulfate ions. So if I'm trying to test for sulfate ions and I put them in myself for making a poor choice of acid, of course I'm going to find sulfate ions because I contaminated my own test. So really the one that I want to use is the hydrochloric acid. That would be my good choice. Now the thing that's a clue to help me make a good choice is I know that chloride ions are safe because I'm putting them in with my test reagent. So if I choose the same ion in my acid, I know I'm going to be on safe ground. So I'm choosing hydrochloric acid because that also has chloride ions in it. So I know that would be a safe combination. Putting that in when I'm looking for those in the first place is silly. Okay, so back to the test. I've got my sulfate ions in the test tube, so I'm going to add hydrochloric acid just to make sure that there aren't any carbonate ions or hydroxide ions in there, and to get it nicely into a solution to start with. And that way it makes it easier for me to see if a precipitate is forming. So I'm just going to give that a bit of a shake and try to get my solid to dissolve. And I hope it will, because I've chosen a potassium salt and I know from my work on solubility that all potassium salts are soluble. I'll add a little bit more. Okay, no, I think that's pretty much all gone. Some tiny little grains left at the bottom. Okay, I'm now going to add my barium chloride solution. So this is the killer, really. This is the thing that proves that I've got sulfate ions present. And if I have, and I know I have, I should see a white precipitate forming. So let's give that one a try. And there we are, a really thick white precipitate that proves that I've definitely had some sulfate ions in my solid in the first place.